Alright, so what we want to do now is try looking at the alumni giving data, the example we've been doing the whole time for this unit, and try to examine the residuals and see if they follow the assumptions that we have with the residuals. So if we go back up, remember we wanted to look at the residuals. That's the error terms, the actual minus the forecast, or the standardized residuals. And we want to plot them on the y-axis against a couple of different things. First, there is against the predicted value itself, and then there's also against the independent variables, whichever ones we're looking at. So if we want to do this for the alumni giving, let's go back, let's grab the data that or the worksheet that we've been using, see if I can find it. Alright, so under materials, unit 3, I've been putting this in Alumni Giving videos. So let's download that. And then I'll open it. And if you recall, the model that we liked the best was, the dummies didn't help us, it was this number 3 subset where we had the highest adjusted R squared and we had 2 independent variables, graduation rate and student faculty ratio. So let's use this model and create the residual plots. So to do this, we used Alumni 2 because graduation rate and student faculty ratio were next to each other, and alumni giving rate was what we were trying to predict or infer something about. So I'm going to go back to data analysis, and run the regression again. We've already done this in a past video, but we're doing it again. The Y range is the alumni giving rate, the thing that we're trying to predict, our response or outcome variable. And then we said we're interested in so I already messed up. H contains the Y variable, the response variable. The X range are in columns F and G. I have labels because I selected row 1. And now the thing that we're going to do differently this time is we're going to check off residuals, so spit out the residuals, spit out the standardized residuals, spit out the residual plots. I personally am not a big fan of the line fit plots, so I'm not going to spit those out. And then normal probability plots. Let's see if that does anything for us. All right, so this right here will be data, residual, standardized residual plots. We'll plot it against each of the independent variables. We'll have to do it against the predicted variable ourselves. So new worksheet apply, click OK. And we see we get the same regression output that we had before over here, right? But now we have some plots, and down below we have residual output, observation 1. Right, these are the observations for each of the rows from the original data. The predicted alumni giving rate, so in the second column it gives us the prediction based off of this formula here with the intercept and the 2 x's, the coefficients for the 2 x's. The residual, and then the standardized residual. Right. So let's look at, I'll keep the normal probability plot for later. We'll look at that last, so let me bring him down here, get him out of the way. Maybe I can get him out of the way. And let's bring, so the first plot that it did was a graduation rate residual plot. So it has graduation rate on the x-axis, the residuals on the y-axis, which is what we're interested in. I'm going to go ahead and zoom in on this, right? It looks like graduation rate, the smallest is probably like 58%, 66%. So let me zoom in with a minimum of 60 and a maximum of 100 because no one's going to have more than 100% graduation rate. And then we are looking at the residuals based on that. So what are we looking for? So remember, we're looking for things that are not out of the ordinary. Do we have about the same number that are above and below the line? Looking offhand, it looks like yes. There are a couple that are a little bit higher up here than they are down below. There don't appear to be any significant patterns that we can discern from this. So overall, this one looks okay. It doesn't look perfect. It doesn't look horrible. So we're thinking perhaps that's okay. Let's look at it for the student to faculty ratio as well. Make this a little bit bigger. And so I'm not going to zoom in on this one. That's okay. It looks like. So again, we're looking for about the same number of dots above the line as well as below the line. We see this one right here is a little bit higher than some of the ones, all the other ones, but nothing extremely out of the ordinary or looks like there's any kind of patterns that can be necessarily discerned from this. So on the surface, it looks like those two are okay. Now we'd like to create a plot. It does not give us the residual versus the predicted, which is what we would like to do. So we can insert a scatter plot. I'm going to select over here in the residual output, Alumni Giving, the predicted, and the residual. Remember, when I do this with a scatter plot, the X will be on the left and the Y will be on the right hand side, which is what I want. I want the residual on the Y axis. So I do that, and I'll go to Insert, Scatter Plot, and bring it down here and make it bigger. Alright, so let me get rid of some of these grid lines. So, I plotted the residuals, but actually I kind of prefer the standardized residuals that I plot. So let me do that instead. So to do that, that's actually not too difficult. I can select this, and I can go over and say, oh, it's this guy. So what I can do is I can just move it to standardized residuals. Not that one, this one. Right? And I can move the title also. So now it's based on a standardized residual rather than just the residuals. So this makes it a little bit easier. So if you remember your probability and statistics class, as you should, if it follows, remember one of the assumptions about the residuals are they follow a normal distribution with a mean of 0 and a constant variance. So a mean of 0 means about the same number below and above the line, which it looks like we're doing. Normal probability means that 95% should fall within plus or minus 2 standard deviations. That's what the standardized residuals are over here. They're standard deviations. Looks like I got 1 above, 2 above, and none below -2. So 2 out of 48, hey, that's about 95%. So it looks like I'm doing okay for normality just from that. We're going to have a look at something else to verify that. And then we're also looking at patterns. Again, nothing greatly discernible. We don't see like a shotgun pattern for a non-constant variance. We don't see any kind of shapes showing up. We don't see, any of those bad patterns that we had examples of. So this makes me think that, hey, the residuals look to be somewhat normally distributed with a mean of 0 and a somewhat constant variance. One other thing that we can look at is a normality plot. Other softwares call it a QQ plot. And here we'd like to be able to see a straight line kind of going from the origin up to the right hand corner of this. Scaling will affect all that. So there's one spot here that it looks like it's out of whack a little bit. And then there's a little blip right here, but overall, I would say that it's close enough to being normally distributed for the residuals that I'd feel comfortable using this model to make inferences about other colleges or universities that we could get data for. Right. So that's looking at residual analysis for the Alumni Giving example. So I'm going to go ahead and throw this all the way at the end, maybe, and call it residual analysis and upload this to Blackboard for you.